Look around you right now. Nobody is looking at you. Or are they? We've all been there. You're sitting somewhere in a crowd, completely focused on something else, and then suddenly a feeling like a pair of eyes is on you. You turn around, and someone really is looking at you. Is that a coincidence? Or is your body actually sensing something? I was genuinely curious about this. And when I started digging into it, what I found genuinely surprised me, because this topic goes much deeper than it seems. And science has some very fascinating things to say about it. Today we're going to explore this together step by step. From psychology to neuroscience, from evolution to consciousness research, we're going to look at what science actually says about this feeling. And I'll tell you this right now, by the time this video ends, you'll never look around a room the same way again. First, let's establish something. There's a term for this in science: gaze detection. And this isn't just a mystical feeling. Scientists have been studying this for decades. There are laboratory experiments, brain scans, evolutionary theories. This topic is much more complex than we give it credit for, and much more interesting. But first I need to ask a critical question. Does this actually happen, or do we just think it does? This is a very important question, because the human mind is an incredibly powerful storyteller. We love finding patterns, we love making connections, and sometimes we feel things that aren't really there. So in this case, is there actually something going on? The first serious researcher to systematically study this question was British biologist Rupert Sheldrake. In the early 1990s, Sheldrake decided to test this feeling in a controlled setting. He designed a simple experiment. Participants sat with their backs turned, while an observer either looked at them or didn't. The participants simply reported what they felt. Am I being looked at or not? The results were interesting. When people were actually being looked at, they guessed correctly at a rate significantly higher than random chance. Sheldrake repeated this experiment with thousands of people, under different conditions in different countries, and the results were consistent. But the scientific community didn't immediately accept this, because Sheldrake's explanation was controversial. He attributed it to something he called morphic resonance, a theory of connection through invisible fields, and that idea is not accepted in mainstream science. But the experimental results themselves were replicated by others, and they couldn't be completely dismissed. So what was the real explanation? This is where neuroscience steps in and offers a much more grounded answer. Our brains contain a very specialized system. It's called the superior temporal sulcus, and this brain region is specifically dedicated to detecting the direction of other people's gaze. Think about that for a moment. We have a dedicated region of our brain just for tracking where other people are looking. This is not a coincidence. This is evolution. And this system works at remarkable speed. In a study conducted in 2013, participants were shown facial photographs at extremely high speed, so fast that they couldn't even be sure they had consciously seen them. But brain scans revealed something striking. The superior temporal sulcus responded far more powerfully to eyes looking directly at the participant than to eyes looking in another direction. Even before consciousness had a chance to process the image, the brain was already working. This is a critically important finding, because it tells us something profound. Feeling like someone is looking at you begins in a completely unconscious process. Before your brain consciously alerts you, it has already started processing that information, and that feeling is actually your brain delivering a message to you. But how? How does the brain know? Our eyes face forward. Our field of vision is limited. So where is this information coming from? This is where we learn something very fascinating about our visual system. Most people think vision is a single unified system, but it's not. Our visual system actually has two distinct pathways. One is called the ventral stream. The other is the dorsal stream. The ventral stream handles conscious vision. It processes colors, shapes, details. It answers the question, what am I seeing? The dorsal stream, however, is much faster, much more primitive, and operates largely below conscious awareness. It answers the questions, where is it? How fast is it moving? Is it a threat? And gaze detection happens along this dorsal pathway, meaning before you're even aware of anything, your brain's lower systems may have already registered that gaze. This is sometimes called blind sight, seeing without knowing you're seeing. There are some remarkable clinical cases that support this. Some patients with damage to their visual cortex report seeing nothing at all consciously. But in experiments, when they're asked to guess whether someone is looking at them, they perform significantly better than random chance. They say they can't see anything, but their brains are somehow still receiving that information. I found this genuinely astonishing. Now let's move into the evolutionary dimension, because the answer to why this feeling exists is hiding right here, and it's a truly compelling story. Eyes carry very special meaning throughout the animal kingdom. Detecting that a predator has fixed its gaze on you could be the difference between living and dying. Think about it. A lion selects one animal from a herd. If that animal senses the lion's stare and runs in time, it survives. If it doesn't sense it, it doesn't. This is why gaze detection is an evolutionarily critical ability, and natural selection refined this skill over millions of years, not just in humans, but across many animal species. There's fascinating research supporting this. Many animal species have developed automatic responses to direct eye contact. Certain butterfly species have evolved eye-like patterns on their wings, specifically to startle predators, because the perception of eyes triggers a danger signal in the nervous systems of many animals. In humans, this feeling has taken on a social dimension, because we don't only use this system to protect ourselves from predators. We use it to read social hierarchies. Who is looking at me? Is this a threat, interest, authority? The answers to these questions matter enormously in social life, and the brain developed a very fast, very efficient system to answer them before consciousness even engages. The body is already preparing. Now let's go a little deeper into how this brain system actually works, because there's a very remarkable structure involved here. The amygdala, the brain's emotional processing center. It plays a critical role in threat detection, fear responses, and social evaluation. And research shows that the amygdala responds with particular intensity to direct gaze. In a brain imaging study conducted in 2005, participants were shown faces looking directly at them and faces looking in another direction. Faces with direct gaze activated the amygdala far more powerfully, and this activation occurred before the image was consciously processed. So the brain starts processing socially important information before you've even registered, "I saw something." This system is so fast that researchers call it the fast pathway. Visual information normally travels to the visual cortex, gets processed, analyzed, and becomes conscious perception. But threatening or socially significant visual information sometimes bypasses this longer route entirely. It goes directly to the amygdala, taking the shortcut. This shortcut is so fast that the body can produce a response before conscious awareness catches up, meaning your body may have already started reacting before you even understand what you're reacting to. I think that's extraordinary. Now let's address a question that comes up constantly. What about cameras? If someone is watching you through a security camera or looking through a one-way mirror, do you still feel it? There are studies that tested exactly this, and the answer is no. In camera or one-way mirror situations, this feeling is not triggered, or at least not at a statistically meaningful level. This is a very significant finding, because it tells us something important. This feeling is not supernatural. It's not a power that operates beyond our five senses. It appears to be a system based on physical signals. So what are those signals? We don't know precisely, but there are theories. One theory points to ambient light and eye reflection. When someone looks at you, the whites of their eyes and the reflective surface of the iris reflect light in a very specific way, and this reflection creates a tiny but potentially detectable visual signal. Our unconscious visual system may be picking up on this signal. Another theory draws attention to the role of peripheral vision. At the edges of our visual field, we can't see details clearly, but our detection of movement and direction is far more powerful. Someone turning their head, shifting their eyes toward you, creates a small but detectable change in the peripheral field. And the brain may be processing this change before consciousness is involved. These theories aren't fully proven yet. Science continues to investigate this, but the fact that cameras don't trigger the feeling does support the physical signal theory. Now let's talk about something I found truly fascinating: the social power of eye contact. Because gaze isn't only about threat, it's also about connection. Research shows that eye contact is an extraordinarily powerful social signal, and the brain processes it very quickly. In a study conducted in 2016, two strangers looked into each other's eyes for 10 minutes, just 10 minutes. And afterward, these individuals reported feeling a significantly stronger sense of bond and closeness toward one another. This is deeply thought-provoking. If eye contact can create this kind of bond, and the brain processes gaze this automatically and this fast, then feeling like someone is watching you may actually be a byproduct of this entire social bonding system. We are a social species. We lived in groups, we survived in groups, and within those groups, tracking who was looking where was critical for both avoiding danger and reading social dynamics. Who is making eye contact with the leader? Who is looking at my food? Who spotted the danger and where are they looking? The answers to these questions were vital for survival, and the brain built a very powerful and very fast system to answer them. Now let's come to perhaps the most interesting area of all: collective gaze. This is called joint attention. It means this: when we see someone looking in a particular direction, we automatically look there too. There's a beautifully simple experiment that tests this. One person stands on a busy street and looks up at the sky. What happens? Within a few minutes, people around them start looking up too. Why? Because following the direction of someone else's gaze is an automatic process in our brains. This begins remarkably early in development. Research shows that babies as young as 9 to 12 months can already follow gaze direction. They turn their heads toward wherever someone else is looking. This is not learned behavior. It is a biological program, and there's an evolutionary reason for this program. If someone in the group has spotted a danger, and they're looking in that direction, the others need to look too. The fastest way to share information without words, with just a glance. Now let's explore a dimension of this topic that very few people know about: blindness and gaze detection. This part genuinely moved me. Research conducted with visually impaired individuals has produced some very intriguing findings. Some individuals who have been blind from birth learn facial expressions and gaze direction through tactile experience, but their social gaze perception closely resembles that of sighted individuals. What does this tell us? It suggests that gaze detection is not based solely on visual processing, social bonding, tone of voice, body language. All of these are part of this system, and this is a really important point, because we don't detect gaze only with our eyes. Our entire social signaling system is involved. Now I can't move on without asking this question. Do animals experience this feeling too? Yes. And there's fascinating research supporting it. Studies conducted with dogs show that dogs are remarkably skilled at detecting human gaze. When a human looks at their dog, oxytocin levels in the dog, the bonding hormone, rise, and the dog looks back. This mutual gaze is part of the powerful bond between dogs and humans, and researchers view this as an evolutionary product of domestication. As dogs began living alongside humans, the ability to read human gaze gave them a survival advantage. Wolves, however, actively avoid direct eye contact, because in a wolf pack, direct eye contact means a challenge. This difference is fascinating. Two animals evolved from the same ancestor, but one evolved toward human gaze, and the other away from it. The social environment shapes even gaze perception. Now let's come to the most mysterious dimension of all: unconscious eye movement. Researchers notice something remarkable. When people enter a room, without realizing it, their eyes immediately go to the eyes of the other people there. This is an automatic eye movement. We can't control it. This is called gaze orienting, and it happens so fast that it precedes conscious awareness. In experiments using eye tracking technology, when participants looked at a scene, the first place their eyes went was to human faces in the scene, and specifically to the eyes. In the process of reading a scene, the eyes automatically search for gaze. This system is so sensitive that it responds even to cartoon eyes. Just two dots on an oval shape activates our brain's eye detection system. This is why images are so powerful. Those two dots read as eyes to our brains, and our brains respond to them. Now let's bring all of this together. You feel like someone is looking at you. Where does that feeling actually come from? We can see that multiple systems are involved. The dorsal visual pathway processes gaze direction information at an unconscious level. The amygdala responds to that information instantly. The superior temporal sulcus tracks gaze direction, and all of these processes begin before consciousness gets involved. Then the body responds. A slight tension, a rise in alertness, and that familiar feeling: someone is looking at me. This system isn't perfect. Sometimes we're wrong. Sometimes we feel watched when we're not, and sometimes we miss it entirely. But the existence of this system and the findings of decades of research show that this feeling is not pure imagination. There's real biology underneath it. There's a real evolutionary story, and a system built over millions of years is still running inside you, still working quietly every single day. And I find that extraordinary. Without noticing, without controlling it, your brain is constantly scanning the environment. Who is here? Who is looking at me? Does this information matter? Millions of years ago, these questions were about physical survival. Today, we're still asking them, because biology doesn't change that quickly. The next time you feel like someone is staring at you, and you turn around to find they really are, pause for just a moment. Underneath that feeling is a system millions of years in the making, something inherited from your ancestors, still quietly running inside you. Thank you so much for watching this video. Chasing down topics like this and sharing them with you brings me genuine joy. If you find yourself wondering about things like this, I would be so happy if you subscribed and came along with me. Every week I follow a question like this one, and I want to discover the answer with you. See you in the next one.